Hello, geometry students. Today is day 4 of our unit 6, and we're going to start talking about trigonometry. So you've probably heard of trig before. To develop the idea here, we need a ruler in centimeters and a protractor. Lucky for me, I have those things floating around, my house. So I'm going to do some of these with you, but if you have it at home, feel free to try this along. Right? We are asked to measure all these segment lengths and then one angle measure. So since I've got my protractor in hand, let me start with the angle measure. So if I line it on up here, angle A, and line it up here, it looks like I'm right about 25 degrees there, which seems reasonable. Looks like an acute angle. As for the rest of these, we got to use our ruler, and look what I found in my drawer, an old Simpsons ruler, probably from when I was a kid. So here we go. All right, if we line it up in centimeters, we want to go to like the nearest tenth here. And so this would be about, 3.2, let's say, centimeters, right? And then I can slide up so that DE right here is coming out about 4.7. And now if you're trying any of these on your own, you might end up with slightly different answers, but we should be pretty close. FG I've got as 6.3. As for the other 3 distances I asked for, they all run along the same line. So if we line it up here, A to C, we'd be at, let's see, right about 7.5. And then A to E, we're about 11.1. And then last one, A to G, ooh, that takes me all the way to 15. All right. So if I label my diagrams as well, it might be helpful to see it. So 3.2, we said this was 4.7, this was 6.3. And then this first length, let me start here, with 7.5. This guy was 11.1. And then finally, the whole darn thing, is 15. All right. When it says, what is the relationship between the triangles? Well, think about the unit we just finished. They all have angle A in them. So ABC, ADE, and AFG. And then they all have a right angle. So that means all of the triangles are similar, right? It'd be by angle similarity. That's what we know there. So similar triangles imply what? Well, they imply equal angles, but then also proportional sides, which means the ratio of the corresponding sides should be equal to one another. Right? So if we use those lengths and set up the ratios, they should come out equal. So let's try it. So it says, let's look at the ratios of the side that's opposite angle A and then to the hypotenuse of each. So opposite of angle A and then over the hypotenuse of that particular triangle. So in triangle ABC, the side opposite angle A, that would be this guy, the 3.2. This would be our little hypotenuse. So it'd be 3.2 over the hypotenuse of 7.5. All right, now let's take a look at the next triangle. In triangle ADE, we'd be going all the way over to here. So this would be my opposite side, which would be 4.7. And then the hypotenuse of that triangle goes from A to E. That was the 11.1. All right, and then in the last case, AFG, that big triangle, I got my yellow highlighter here. I go all the way over here. So this is the opposite side right here, the 6.3, and then that's the hypotenuse there. So this one would be 6.3 to 15. All right. If we divide these out, they may not like math frack into nice answers. So our best bet is actually to turn them into decimals so that we can compare them. So let's see, if I take on my calculator 3.2 divided by 7.5, that gives me 0.426 repeating. All right, let's see what the next one came out to be. 4.7 divided by 11.1, 0.423. And it keeps going, and 4, so on and so forth. All right, the last one, 6.3 divided by 15. I get 0.42 exactly. So if I look to at least about 2 decimal places, those are pretty accurate. And those are based on my measurements with a Simpson's ruler from when I was in like the 4th grade. So we're looking pretty darn good here, right? So when it says, are the ratios equal? For the most part, yes, all right? So we divided them out, we compared the decimals, all right? They're not perfect, but they're pretty close. So when it says the ratios are blank because they're all based off the same angle, it should be that the ratios are equal because they're all based off the same angle. And that angle was angle A, which we said was 25 degrees. So this ratio, right, is equal to what's called the sine of A. So the ratio we looked at in particular of the opposite side divided by the hypotenuse is referred to as sine. So trig terms that you may have heard before, sine, cosine, tangent. Sine specifically just represents this particular ratio. So the opposite side divided by the hypotenuse. So down here when it says using triangle ABC, since sine of 25 degrees was equal to, that was the one that came out to be like 0.426, repeating. It's saying use your calculator to check. Well, on your calculator, you're going to notice that you should have the buttons right here, sine, cosine, tangent. Now, the one thing that you do need to double check is that you're in the correct mode. So if I hit the mode button right here, I'll zoom in a bit to make sure you guys can see. So if I hit mode, I need to be down in degree mode. Oops, sorry. Let me try that again. In degree mode. So make sure degree is highlighted there. If you are not in degree mode, it is going to mess up your answer. All right, so take a minute and fix that on your calculator if need be, so that it's highlighted on degree, and then you can quit out of there. And now what I'd like you to do is I'd like you to type in, so hit the sign button, it'll open up a parenthesis, and then of 25 degrees and close it up. So when you hit enter, that is the ratio that we should have came up with. So we did it 3 times over, and we came up with answers that were pretty darn close to that, right? So on the calculator, sine of 25 comes out to be 0.4226 and so on, right? And that's what I was saying right there about you have to be in that degree mode. But it checks out pretty well. We did a pretty good job. So the nice thing is the calculator has all of these ratios stored for us versus us having to find the ratio by getting out our ruler and protractor and measuring. So when we move on over to the next page, there are those other ratios that I mentioned. So the first one, so sine, which we abbreviate, and it does look like sin, all right? So sine of the angle, so I'm going to say of like angle A is equal to the opposite side over the hypotenuse. And then there's something called cosine, which on your calculator you're going to see as COS. It looks like cos, right? This one is equivalent to the length of the adjacent side over the hypotenuse. And then the last one, tangent. Tangent can mean many things in mathematics, but in this case, the tangent of a particular angle A is equivalent to the ratio of the opposite side over the adjacent side. And so when I keep saying of A, let's draw ourselves a little triangle over here. A has to be an acute angle in the triangle, in my right triangle. And then this would be the side opposite. The hypotenuse is pretty obvious. That's across from the 90. And then the side next to it, that's what I'm referring to as the adjacent side right here. So it's those 3 side lengths that you're using in these ratios. And so some shortcuts that you might actually see, and it's pronounced SOHCAHTOA, is that people will show this as so to represent sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and then TOA, tangent equals opposite over adjacent. Honestly, I've heard it like that for so many years, it's just stuck in my brain. There are other little ways in mnemonic devices to remember it, but SOHCAHTOA is a pretty commonly accepted one, right? So all we're doing down at the bottom of the page here is just practicing using those ratios. So since this first one is all about angle A, mark angle A, and then I want you to label the sides with the opposite, the hypotenuse, and then the adjacent, or even O, H, and A will do. So the sine of angle A, that's the opposite over the hypotenuse. That's going to be 5 over 13. And that's as far as you need to go. The cosine, that's the adjacent over the hypotenuse. So that would be 12 over 13. And then last one, the tangent. Tangent is the opposite over the adjacent, so 5 over 12. There are actually 3 more ratios beyond sine, cosine, and tangent, but you talk about those next year in Algebra 2. All right, so take a moment here, and I want you to try this one. And so if this is B, here's the opposite. Here's the hypotenuse. Next to it would be the adjacent. See if you can fill out those 3 trig ratios, and feel free to pause the video if need be. All right, so right here, when it says there's a special phrase to remember, here was the SOHCAHTOA. There are other ones as well. We can talk more about that in class. All right, so what this is actually useful for is that we can use these ratios to solve for missing sides or missing angles in the triangle. So today we're going to focus on finding the missing sides. So when it says use right triangle trig to find the side length, we're going to set up a proportion. That is our goal. All right, I have a 21-degree angle. X is the side opposite of that. Across from the 90, that might be my hypotenuse. And so what you have to do is look at which sides you have to work with. So since I have the opposite and the hypotenuse, I have the O and the H. So come back up here and look. The one that uses the O and the H, that would be sine. So I'm going to use the sine of my angle, and that's equal to the opposite over the hypotenuse. Now let's fill in the blanks. What we know, the angle is 21 degrees. The opposite side is X, the hypotenuse, 17. When I say set up a proportion, you can leave it like this, or I can throw this even over 1. That's what I meant by that. So now if we multiply to solve, if I multiply this, I would get X. If I multiply that, I end up with 17 times the sine of 21 degrees. And so into my calculator, that's what I'm going to type in. So 17 times the sine of 21, that should come out as 6.09. So to the nearest tenth, we can say 6.1. So that has to be the length of that side based on the ratio for the angle 21 degrees. All right, let's try it again. This next one, here's my angle. All right, this would be the opposite. Here's the adjacent. This side's the hypotenuse. So I only use the 2 sides that are labeled. So I have the adjacent side labeled, and I have the hypotenuse labeled. When you come back up here, adjacent and hypotenuse, that's the C, that's the cosine. So we're going to use cosine. So cosine of the angle is equal to the adjacent over the hypotenuse. And so this A right here, I just mean by the angle. If that's going to throw you off, you can actually use something called theta. Theta always represents an angle. So you could put a theta there if you like. Otherwise, let's put the numbers in. Cosine of 43 degrees is equal to the adjacent side, X, over the hypotenuse, 25. And then we're going to do that same thing again. If you don't want to show it as cross multiplication, you can just simply think of it as I have to multiply 25 over to then solve for X. So 25 times the cosine of 43. Grab your calculator. 25 times cosine of 43. That'll give me 18.28 and change. So to the nearest tenth, 18.3. That has to be the length of that side of the triangle. So we do have more to practice here. Let me just quick peek. All right, so maybe let's finish these last 2 together, and we'll save that last page for practice in class. All right, for this one, here's my angle. This is the side opposite. This is the hypotenuse. Here's the adjacent. but the only ones I have to actually work with are the opposite and the adjacent. So when you go up and look for opposite and adjacent, that's that last ratio. That's the TOA, or the tangent. So we are going to be doing tangent of the angle 33 and then equals opposite over adjacent. All right, let's multiply. So x is going to be equal to 9 times the tangent of 33 degrees. So 9 times tangent of 33, we end up with 5.84. So to the nearest tenth, that length should be 5.8. All right, last one together in the notes. Here's my angle 56. Here's my opposite. This is my hypotenuse. Here's my adjacent. The only two sides that are labeled, though, are the adjacent and the hypotenuse. So A and H, that's going to be cosine. So cosine of 56 degrees equals the adjacent over the hypotenuse. All right, multiply that 14 on over so that we get 14 times the cosine of 56. So 14 times cosine of 56, that will give us 7.8 and change, but to the nearest tenth, 7.8. Yay, you did it. All right, great job, guys. Talk to you soon.